Hello, and welcome to the FIB Young Members Group new podcast series. My name is Nikola Tošić, and I'll be your host for today's talk, where we'll meet the fantastically energetic, inspiring, and immensely successful Dr. Mladena Luković, Assistant Professor of Concrete Structures at the Delft University of Technology. For those of you who don't know, the FIB is the International Federation for Structural Concrete, an international organization with almost 50 national member groups dedicated to acting as a bridge between research and practice in the field of concrete structures. The FIB also boasts a very vibrant Young Members Group, or YMG, that aspires to give a voice and platform to young engineers, be they researchers or practitioners, to network, learn, and collaborate. The FIB YMG organizes live events around FIB symposia, networking and social events, a very popular webinar series, and many more. For more, check out the FIB website at www.fib-international.org, as well as their YouTube channel, Twitter, and LinkedIn accounts. Our today's guest is a world-renowned researcher who has just received the prestigious 2016-2020 International SECO Magnel PhD Prize, among other recognitions. As I said, Mladena is assistant professor at TU Delft, without a doubt one of the best research institutions in the field of material science and structures. Mladena's impressive scientific career started 10 years ago when she became a graduate student at TU Delft and worked on her PhD thesis, Influence of Interface and Strain Hardening Cementitious Composite Properties on the Performance of Concrete Repairs, in the renowned TU Delft Micro Lab. Since then, Mladena has published 38 research articles, all of which were cited almost 1,000 times. Mladena is very active at TU Delft, heading a research line upscaling new concrete types, where she is supervising 3 PhD students at the moment. She is also very active in the FIB, playing an important role in the organizing committee of the FIB 2017 Symposium in Maastricht, as well as RILEM, where she is a member of the technical committee Mechanical Properties of Alkali Activated Concrete. Mladena principally deals with the upscaling of new and innovative types of concrete. Within her new research line, she focuses on hybrid structures, concrete-to-concrete interfaces, strengthening, application of lattice models for structural analysis, coupling physical and mechanical aspects of predicting the long-term behavior of hybrid structures made of innovative concrete types. Besides research, Mladena is a great teacher and an active science communicator through her blog in the Dutch magazine on concrete structures, Cement. But above all, Mladena is a long-time and dear friend, whom I studied with during our undergraduate studies at the University of Belgrade's Faculty of Civil Engineering. I promise we won't go into all the fun stories we share from the university, but we might mention some. Thank you for joining us and enjoy the podcast. Hi Mladena, thank you so much for joining us. Welcome. We're really thrilled to have you here. I'm looking forward to a great conversation, to hear a lot of great insight and input from you for all the young engineers out there. We get both, let's say, your experience, also some career advice, research advice. I think there will be a lot of topics to cover. And right off the bat, so congratulations on winning the 2016-2020 International SECO Magnel PhD Prize, right? How does that feel?
Yes.
I mean, were you expecting it? I had a sensation from you that not. So please, tell us a bit about that.
Okay, first of all, hi Nicola. I really feel honored to be invited by you. So thank you very much for this invitation. And it's also nice to be back in this nice chat conversation with you. So it feels like we are back in our student time. So not really very official. So yes, as I already told you, this prize actually came as a total surprise for me. So I applied, of course, and whenever you apply, you hope that you might win. But here I thought, okay, yeah, I apply, but I thought that my chances are not that high. But then one night I was checking my emails, and then I saw the email that started with, oh, the competition was very hard, and I already saw it coming. I did not get it, but then it was, but you are the chosen one. So it was almost a wake-up call for me, and super large surprise to see that I won. So
really, congratulations.
It's a great experience.
I think that the name of Magnel is really world renowned. So having this kind of prize is really a contribution. I mean, your work is recognized very both within Violin, within the FIB and internationally. So really just a well-deserved award and recognition of your work. And I mean, as I understand, this award was primarily for your PhD topic, right? For your work during your PhD studies. But can you tell us a bit about what you are working on now? What's your latest publication? What is now a bit your research directions, or what you're dedicating yourself to now?
Yes, so my research during my PhD, it was a bit in material direction. So actually my background is structural engineering, but then when coming to TU Delft, I started PhD research in material group. So that was on a new type of concrete named strain hardening cementitious composite, or SHCC, which can be used maybe as a promising material for durable repair. So then I investigated in my PhD a lot of parameters that influence the behavior of concrete repair. I studied the moisture transport between two materials because this governs the development of material properties at the interface and the repair material itself. And then I studied the influence of different boundary conditions on this long-term performance of repair. And that research, although it's in material group, it already had some parts, let's say, connection with the structural. Why? Because, concrete repair its structure itself, because it contains repair material, all the existing concrete and this interface. So it already had the parts of the structure, let's say, but it was mainly in the material direction. And then in 2016, I came back to, let's say, structural engineering in the group of concrete structures at TU Delft. And here my main research line is upscaling these new concrete types and bringing them to structural applications. So SHCC is only one type of this new, let's say, innovative material. Now, drive with this geopolymer, for example, concrete, which is also not that new because it was used also in 1930s and 40s in Soviet Union as an alternative solution for cement-based binders. So that's one type of concrete that I'm addressing. Then strain hardening cementitious composite indeed. Then ultra-high performance concrete. And many new types of concretes that have been developed recently in material labs. I'm trying to find promising structural applications for these new concrete types and bring them to applications. So that's now my goal. Okay, so actually this background of both material and structural brings me in a good position to upscale these new types of innovative types of concretes.
Yeah, this appears to be in general a very good, let's say, higher added value to research if you're kind of bridging several scales of research, or let's say several stages or phases, material, structural, and that brings me. So as you were talking, my association was to ask you a bit about how you square this circle of let's say looking for new research topics, or how you look at it at a personal level, because I guess like doing the PhD, each one of us like gets really deep into one specific topic, but then you realize, right, that I mean you've taken it very far, but now if you want to pursue an academic career in research, you kind of need to step a bit back, look at a bit of a bigger picture and branch out into new directions. Sometimes maybe a bit psychologically, this can be also painful or difficult, that you have to kind of give up your let's say baby, I mean the research that you're doing, and start new things. What's your feeling about that? Do you personally like this, like going into completely new topics, carrying with you your expertise, or you prefer staying very close to any things you're doing and then kind of incrementally going into new directions? What's your sensibility on this, or how you think about it?
Yeah, I do like jumping in different topics, because I think that's also the only way for us to grow. That was actually already when I started PhD. At that time, the structural engineering of my studies, concrete was a number, so I knew what is the strength class. But then in material group, you have to learn really in details this composition of cement. And I was, okay, what is C3A, what is CSH, I was lost completely. And then you go in depth in this material, let's say, field. And then the value that and the knowledge that you have also related to structural part becomes, let's say, more valuable. And then also when coming back actually to structural engineering, then I felt again as someone that is behind, because my actually PhD research was mainly in material directions. And then I thought, okay, yeah, actually I have this background, but I never did research in structural concrete, for example. So then I again felt a bit behind. But that also gives us space to grow, because it also gives us a challenge. So then you think, okay, I'm behind, I need to learn fast. And that is actually what motivates me to go ahead.
Yeah, I think
so also,
sorry.
So yes, so also when starting in 2016 in this group, so then I had my, let's say, first task to look for existing literature, what has been done with these new types of conflicts worldwide, and what has been done in the Netherlands. And then I again felt like starting a new PhD. But I think that we always have, even when you start writing a new article or a new paper or a new proposal, you again feel as if you're starting your PhD. You again need to do broad literature study on this topic. And then you can go in depth. So I think that's actually a fun part of doing the research.
No, that's a great way of looking at it. It was just my thought that, yes, we tend to have this feeling in academia, right? In research, everybody talks about like imposter syndrome and feeling in many topics actually that you don't know anything, and it can make people feel insecure sometimes and cause anxiety. But on the other hand, there are people who are hooked to this feeling of, let's say, feeling that you don't know things and that you need to learn. But yeah, so what's your way of coping with this? How do you say to yourself, okay, maybe I don't know here that much, but I actually do know a lot. So how do you kind of stop and say to yourself, you're smart, you're intelligent, achieve a lot. Like what's the advice to people who might feel overwhelmed sometimes, like, oh, I don't know about this topic, anything. I'm like, the worst expert in this area or something. But how to step and take a look back and like probably see the way you've passed already. Like what's the mechanism there? How to cope with this overwhelming feeling, I guess.
Yeah, actually with this imposter syndrome, yes, I really, I'm really familiar with that. Actually, also here in Delft, so when you should defend your thesis, you write, I think the usual number is 10 propositions, which can be either related to the research itself, but it can also be related to anything in your life. So it's also to your view on some things. And one of them for me was related to this underdog position. So I will need to go back, maybe to read it, to check exactly how I said. But actually I really feel it. And I think this can be only so I don't know if I reach, sometimes yes, indeed, I reach this moment, okay, I might be smart. So for example, with this award, then you feel like, okay, you get recognition, so what you do. But I think I generally, 80%, 90% of my time, not maybe to say even larger, so not to demotivate young researchers, I have this imposter syndrome, so that I think I'm underdog. But that actually, I think it's also good, because then you have drive to dig more, to learn more. Because if you always think that you are on the top of the hill, then it's also not nice, because then you tend to underestimate things.
Yeah.
So I think, yes, mentally it's difficult. And I had it especially during my PhD. Then because that is a long way to reach this end of the project. So it's 4 years and you are alone. You have to solve your own problems. There is maybe 1 or 2 persons in the world that can help you, or maybe no one that can really help you. No one was as busy as you are with a certain topic. What I then tried to do is maybe to publish small parts of my PhD. And then you expose your work to the critics, and that helps when you have a good critics, and then you also learn from it, but then you also get recognition. And for me, I think that helped me to deal with it. And I think now as well, that's the way for me to deal with it. So just expose my work to critic, and if you get positive critic, that's great. If you get negative, it's also great. You learn from it. And I think, at least for me, this is the way to deal with it.
Yeah, no, I agree. As long as it doesn't, you shouldn't have, I guess, to paralyze you, right? It should become a motivation. So, okay, I don't know, but I want to work on bit by bit, like you said, publishing bit by bit, and then learning from every new step, just not getting paralyzed. Okay, so, well, now coming back maybe a bit to research now, you mentioned publishing and receiving, let's say, reviews and so on, and now that you have really recognition for the work you have done in the past and are doing now, from this position and knowing what you do up to now, like, and let's say more closely your area of research, what do you see kind of the future holding in terms of directions of research, or what is something that you would now be passionate about dedicating yourself to in the future? Like, what do you see very interesting and important? They don't have to, I guess, coincide always, these two things as topics for research.
Yeah, so I do think that one of these is, I think, my research line that I'm doing. Otherwise, I would not be doing. So I strongly believe that we really need to find, let's say, more sustainable, more green solutions to our current solutions. So that, given the current societal demands and challenges like CO2 emission or waste landfilling or scarcity or raw resources, that we really need to find more a better and, let's say, more smarter solutions, that we need to think about, let's say, future generations to come. And that's already quite a huge task, because I think that as in general with concrete structures, we tend to be sometimes too conservative, because, for example, we rely also on design codes, on our experience, long-term experience, also long-term experience with the behavior of concrete structures that we have by now. But I think in future we would need to act much faster. So, to look for alternative binders, to look for alternative materials, and that with these let's say, new innovative solutions, that we try not to affect the serviceability, let's say, demands that we have, with already existing concrete structures. So also that we do not affect the long-term behavior. And that's always also difficult to predict because, for example, if you have a new binder, you don't know if it's susceptible to freeze-thaw reaction, to freeze-thaw exposure, or it might be susceptible to, I don't know, CO2 emissions, to CO2 exposure, or there is a even completely unknown mechanism that might not be valid for, let's say, concrete structures at all that we have for cement binders that we have for now. So I think that's the challenge that we have. And so for the engineers to come, I think the task for the generation, let's say, to come, I think the task would be maybe even much more difficult than it was in the past. Because we would also need to deal more with the existing structures, maybe with the reuse of structural elements and the reuse of concrete itself. So I think that there is really serious task that would come, and there is a challenge. The challenge is that we do not have experience. We do not have codes, let's say, for these new type of concretes or for these new solutions. It's also difficult to get permissions on using them. So we would really need to act fast. And it's also because it's innovative solution. You know, sometimes I also think innovation doesn't go with codes together because, you also do not have time, to build and to spend on, getting all the regulations in the same way that we had with the regular concrete structure. So I think this intrinsic engineering thinking would need to come back also with our future engineers. And
what do you think? I think now is actually, my feeling is like, I would say ideal, but really a great time to be doing this kind of research of, let's say, more sustainable concrete structures and doing this, well, what is called now this green transition, precisely because somehow there is a feeling that it's finally really recognized at the policy level, at the EU policy level, at research funding level, right? So Horizon Europe, I think now has quite a lot of focus on that and quite a lot of funding instruments. So it's really a good time to be involved in this area. It's kind of seems that the fruits of labor are paying off for this. I feel that for a lot of solutions, for a lot of these, let's say, challenges or problems, sometimes avoid this word, I guess, challenges, right, instead of problems. We kind of know what we have to do and what are the solutions. It's now my feeling, I don't know what's your take on this, a question of this multidisciplinary collaboration with other sectors and knowledge transfer to industry. So now this kind of market uptake. So how to approach this? I mean, you are involved in a lot of, let's say, preparing a lot of project proposals, European projects, precisely on this digital transition, like twin transition is green and digital transition, where we now as engineers have to collaborate with a lot of different sectors so that, let's say, the industry and civil society, everything can uptake these results. So who are the, let's say, stakeholders that we have to address and talk to, collaborate with, and to whom we have to transfer our knowledge, because we know a lot of stuff already. Okay, there might appear a new binder and we don't really know its sulfate resistance under 60 degrees Celsius, right? But that's a research topic, but we already know in broad strokes what are the solutions for a lot of these challenges. So who do we need to talk to and how do we make our voice heard and listened to in a way?
Yeah, I think first ourselves, we also need to become more, let's say, multidisciplinary. We also need to, let's say, expand our knowledge. So especially with these, for example, new types of concrete, you would need to deal with, let's say, coupled thermal, hydral, mechanical effects. So, and also in developing, let's say, more models, and better models to understand their behavior and long-term performance. So that's important. So we ourselves, we also need to go more, let's say, multidisciplinary, also to work with even different disciplines, even within civil engineering. So, for example, what I see, what I think in past was more the case that, okay, concrete structures, we're working only with concrete structures. But now I see more that there is also interdepartment collaboration. So that becomes important. So, for example, with different, let's say, people that are busy with monitoring, as long as you want, to use new material and with which you do not have experience nor codes, you also want to think about new monitoring techniques, to be able to warn you, when something is wrong. So then you also again need to go and look for specialists in this field. But also in general, when making these proposals, we also need, I think what I try to learn is also to communicate clearly, what my goals are. So we are, let's say, technically busy, and these details are not important, let's say, to social scientists, with which we also need to collaborate with this, on this, let's say, large scale projects. So also how to communicate our science, how to communicate our science, but also how to approach our science to, let's say, broad audience, so that they realize why it's important. Why do we do this? And I see, for me as a technical person, it's still sometimes difficult, even when being involved in these large consortiums. When I talked with the specialists on the social sciences, for example, that I still have difficulties in understanding them. And I guess with them it's the same when we start talking. So more and more you see that we have to learn the language of each other. To be able to communicate. And in that sense, I think that it's really important that we work as one circle, that we are able to work with each other. and not to stay in our own niche. So, I think it's also like with civil engineering in general. First it was architecture and civil engineering, but then you go more in this niche and everyone becomes specialist in their own field, and then you cannot go back and look, and then you get a lot of interfaces as well. So you have your own field, you have then the interface with the other field, and then it again becomes communication problem. But I think for a while we were busy with our own niches, and now again we need to go back and together solve these large societal challenges that we have. So, but I have to admit, for me it's still difficult. I think I do take part in these large consortiums, but I think there is a long way to go until maybe I would be able to lead one, So it's, for me, I'm still very busy with the technical part, and I do not see the whole really picture.
Yeah, do you think, probably there is also a bit of aspect that we have to kind of lose our ego in a way, because in all of these projects we have to realize like we're just part of it and maybe just providing a service towards a bigger objective. Especially, I guess, when you get stuck and spend so much mental energy, developing constitutive equations, that's really intellectual work. Then you say, how can this not be the most important thing in the world, right? And it can be in the end just a part of a bigger picture. But you mentioned also this kind of communication between disciplines, and then there's also this importance of general, like popularizing science and let's say communication with the general public. Well, we all see like recent years have really like brought to the forefront this science skepticism and so on, like as there are flat earth and anti-vax movements. God forbid we get civil engineering skeptics who don't believe in impartial factors or the safety of buildings. So how to communicate to the general public? You write, let's say, popular science blog in the Netherlands. I'm sure that has helped kind of streamline this process, and which I know from my experience recently writing an article for, let's say, a news portal in Serbia, that I really try to use a language and expressions that I thought would be, let's say, daily and understandable to the average reader. And even for that, the feedback that I got from the portal was like try to simplify it even further. So that kind of surprising. So, like, what are the important aspects to get people hooked to the story and to communicate effectively?
Actually, I think on this part as well, I'm still learning, because yes, indeed, I write this blog, but it's the blog in a magazine of concrete structures in the Netherlands. So I was happy that I was invited by their editor to write this blog. And at the time, I was also super stressed because it's actually Dutch. It should be written in Dutch. So that was the first, let's say, trouble I had. And then it is to the broad audience, but it is still read by engineers. It's read by engineers and then concrete structures people actually. So, but there as well, indeed, you have this challenge to make it readable by anyone actually. And I to be honest still struggle with that. So first you have to find the topic that sometimes it's complex to understand, but then you need to explain it to, let's say, even your mother or father to try to follow it. But then I always also think of the words that one of my colleagues told me. He told me when I was teaching the course. So then he said, if you cannot understand it in simple words, then it means you do not understand. And actually that is the case. So if you want to try to understand something, to try to explain something in very simple words, you will find out that it takes you really a lot of time to find, for example, nice example, to find it understandable to everyone. But once you master it yourself, then you are really able to explain it in a simple way. So, especially, for example, for this communicating science to the wide audience, I find it very important because myself like to look at the other fields, okay, to see what is happening. Of course, not all the complex things I can understand, but I like to be informed. And I think with our science, what we do, we also have this is also our obligation, to share it, to share our knowledge, also to share it even with the younger generations, so, to make it approachable. So I think that it's important that we keep this link between science and communication, and communicating with wide audience, short, let's say. But there are also some, let's say, calls when you see that, audience, of wide public is asked for, things, for example, what we should do research on. And there I do not quite agree. So there are general agendas calls, for example, I think that's the name. So there I do not think, I do not agree. I do find them beneficial maybe, but I do not think that, I do not find it, easy, that someone else can specify what should be the research topic we should be working on. So, because you spend a lot of time, a lot of what you said, a lot of reading before you can, let's say, pinpoint the research topic that is important. So, for example, like simple example, if you ask people 20 years ago, do they need iPhone, for example, they would not say do research to discover iPhone, but now you see anyone is addicted to this iPhone. So I'm not saying that we need iPhone, but even for different kind of medicines, that we need, that I would not know that should be developed. So
no, there was, I think, a good example was by Zizek, actually. I don't know, in some interview, there was like, if you had asked people before the invention of the automobile, right, what would they want for transport? They would say a horse that eats less and goes faster, right? And nobody would have said this, but okay, that means actually the importance of this science communication, because exactly with this good science communication, they will also get, the general public will get a better idea and be able to identify better these new topics. So it has this important role here. So yes, and let's say, not to mean it in a bad way, an uneducated, an uninformed public, yes, they will demand certain things that are not probably optimal from this point of view, but a better informed public would then definitely be a better stakeholder, right, in the entire process. Please.
Yeah, and for example, in that sense, I really think that science should come before, let's say, citizens, so that the scientific world should also pinpoint and say, okay, these are directions that we really need to invest in. For example, I don't know if you have let's say, very broad audience. So now everyone is busy with, for example, CO2 emission. You see this IPCC report. So everyone is now concerned. But I don't know that, I don't know if people would be able to, let's say, pinpoint, okay, these are the main, even if these are the main, let's say, pollution sources. But they also, I think they do not have the whole background. So, for example, if you think about infrastructure, what we always see is that the concrete structures are responsible for 6 to 7% of CO2 emission worldwide. And yes, this is true. But also, if you look at the value of our infrastructure, if you look for the value of global gross national wealth, 50% of this is, let's say, physical infrastructure. And that's 20 times more than the value of all gold that is ever mined. So also this, let's say, growing infrastructure, and that was also from a valedictory talk from Professor Magnel, that I also realized that this, that our infrastructure has really wealth. And there is a huge, let's say, wealth in it, and that we really need to be careful how we deal with it. So yes, it caused probably a large CO2, let's say, emission, but it also caused us so large prosperity that we now have. So now we really need to be smart enough also to turn it back to our advance. And whenever we have these kind of problems, we turn to science, because then science is able to answer these, let's say, also technical questions and give, let's say, good directions for certain demand that we have. So
yeah, this is, I think, a part where we also need like these. We need social sciences and
yeah, exactly,
right, because Yes, I agree. As the wealth associated with, let's say, physical infrastructure is huge, but one part of it is it's, let's say, use value, but let's say it's this socially constructed value, right? In a way.
Yeah.
But these emissions that we are causing, they are physically there. And let's say the climate change is something that,
Exactly.
socially we can attach to it importance or not, but it's there and it's going to make problems. And we need to square this. I think, what we need is this interface between social sciences and these social criteria and civil engineering that have to, for us also to educate ourselves in this more probably on wealth, on economics. All this is important. We're not in this bubble. But I wanted to mention, please.
Yeah, no, but I also think it's also important when we are now talking about also social. I think it's also important to specify our needs. So for example, with this IPCC report, we see that we are causing actually quite some damage. On the other hand, what I read also at that time here in the Netherlands, and that was also one of my last blogs was related to that, is that there was 1 million of new houses that were needed in the Netherlands. And at the moment, the average Dutch person, he or she occupies, let's say, I think 67 square meters. And that's like 30%, I think, more than surroundings, so surrounding neighbors. So, and even then, now we are asking for, let's say, more space, more houses. So, and then we again become very close to social sciences. Is it really our need to have 1 square meter per person? I don't know. When at the beginning of the 20th century, it was 10 or 15 square meters per person. So then what is our limit? When would we say, okay, it's enough?
No, absolutely. There was recently, this also decision in light of this IPCC report and knowing all that we know, and what let's say burden or what impact the wealthiest nations are having, that Norway, one of the wealthiest nations in the world, does not want to give up on, let's say, oil exploitation, right? So
exactly.
one of the wealthiest countries in the world does not want to make itself even a slightly bit less wealthy for the sake of, let's say, less pollution. So then a way forward is really difficult, right? If they that have such a high standard of living, they're not ready for even this kind of adjustment. And then what's to stop, China, India, and the other countries saying, well, we're going to develop further, whatever it takes, coal or whatever. If one wealthy Norway doesn't want to decrease its growth by, a slight percentage.
And what I find the worst is that, those kind of countries are the countries that are most responsible to the problems that we have. So they emit the most. So it's not those countries.
Or were historically, yes. Or even if they, let's say, transition now. So there's this also question.
But it's also, exactly, because those are developed countries. So those are the countries which already developed, so which emitted a certain amount of CO2. And then you have developing countries, which are now, of course, also emitting and starting to emit. But in that sense, I think we also should globally try to be also less selfish. And I think that actually rich countries and developed countries, they have to give example and to invest the most. So, and in this aspect, I think here in the Netherlands, we do quite good. So, they want to set the example. Because I think here you should be really aware of your contribution. And then if your contribution is also large, you should also, or you can afford, let's say, to contribute the most in this, reduction, let's say, or putting us to the right track, you should do it. You should be leader, let's say, and not wait that someone drags you and show you the way.
So this ties into nicely something that I wanted to ask you before, and that you mentioned. You mentioned interdepartmental collaborations, for example, and now you mentioned Netherlands as kind of leading by example, which I agree is one of the most, let's say, innovative, progressive countries in these aspects. in this sense, like, what do you think? We all know, I mean, the performance of Delft on global rankings and so on. So what makes it such a great institution and environment? Like, what are these best practices that you would say that Delft has that maybe others can learn from and try to implement that make it such a good place? I mean, of course, there's this historically good basis, but still, what is it with people, interpersonal relations? What is it with the, let's say, infrastructure, capacity of administrative capacities that make it really a good environment? And what is something that others can use from your example?
Yeah, I find two important things here, and actually both of them you actually kind of mentioned. So one thing I think is reputation. It's circular. So you have to. It's by reputation that good people are attracted by Delft. So and it's the circle. You get good new people, and then you get more reputation, and then you can also generate, let's say, attract more good people. So that's one thing. So you need actually to take care that with the limited resources, you are able to get this good reputation. I think that is how it starts. And then it becomes a circle. Then you just need to maintain it, let's say, and to continue in a similar way. The second thing, which I find really extraordinary here, it's this innovation and it's this science, in TU Delft, I really have a feeling that they are not conservative, that they really encourage innovation. So, for example, when I started here in the group of concrete structures in 2016, there was a group that was just open in steel and composite structures, but it was related to using FRP in construction. So, for example, in FRP, we know it's used a lot in aerospace engineering, in all kinds of, let's say, other engineering sciences, but not really in civil engineering. And I think it was one of the first groups worldwide where they started research on FRP specifically for civil engineering. So FRP application for civil engineering. And that I really find extraordinary, because then they also encourage developing the course on FRP structures in civil engineering. And so they're really not afraid, let's say, of doing innovation and trying new things.
Is that what you would call? You just said, I mean, not afraid. So would you call it like bravery, like intellectual bravery, or not being afraid to make mistakes, or not, punishing people for making mistakes because you're bound to get, or mistakes, let's say, dead ends.
Exactly.
Some things are not going to work by probability, right? So, but being open to, making errors or something like that.
Yeah, I think exactly, being open to make errors, but it's also like being open for innovations. If you get a good person working on this innovation, it cannot be dead end. That brave good person would find a way out. So he would not build, let's say, immediately FRP bridge, but would use FRP material for joints or what is now actually happening. So I think, of course, always you can end up in dead ends, but you can always also find a way to go to succeed if you have, let's say, good boundary conditions for it. And that I find really important, let's say.
Okay.
So I think it's also kind of the trust that you get. That's also important, I think. Even with the PhD, when I started the PhD, I had a feeling that I'm a bit left alone, especially then in the beginning. It was not. Of course, you can ask to have regular meetings, for example, every 2 weeks, but I did not have a feeling that, someone was really looking at me all the time or asking me for meetings. Everything was kind of left on me to organize, to see who I need, how I want to connect, how I want to solve the problem. And on one hand side, that can be more difficult at the beginning. But on the other hand side, I think it gives you much more space to grow. And then, so it's also, you can say it's also more risky, but it's also high, let's say high gain in the end.
Of course, I mean, being completely honest, you are a biased data point, right? Because you're the one who has successfully survived. For sure, but that's the filtering process, I guess. And I want to be conscious of your time and availability, but I have to ask also a bit, since we are here at the FIB Young Members Group podcast, and well, the concrete structures at Delft, they have really greats, such as Professor Valraven, and a lot of contributions that came from Delft. There's a lot of integration between the FIB and Delft. You had, for example, really direct experience with the 2017 Maastricht Symposium, and then even later with other works. I mean, how do you see the role of the FIB in advancing this knowledge on concrete structures and contributing to, let's say, this more sustainable future? There are now initiatives also within the FIB by the new president on sustainability, so it's being pushed from many directions. So how do you feel about the FIB and in your experience of interacting with it?
Yes, so I had the pleasure and honor to be involved in this committee that organized FIB 2017 symposium. So together with at that time Professor of the group, Dick Horley. What I mentioned in the beginning, that concrete structures world, it's a bit conservative, especially if you compare it with you mentioned auto industry. They are quite changing, they are quite adapting, they are quite open to innovation, even to pharmacy industry. Why? Because they invest also a lot in research, so I think the pharmacy industry, from all the turnout, 20% is invested in research annually. So, which means that they know that if they do not invest in research, that they would fast fall back, So, that's very important. And I think that, FIB is also showing the way how to deal with these all innovations. So, for example, I like that there is a young, FIB group. So that also gives, importance to the young engineers to come. So that there are also more working groups on sustainable, concrete types or new concrete types, on innovative structures. And I think, and also, for example, in this 2017 symposium, we saw that there was a student competition and now FIB also continued with this, the same event, so that you can see also now in a further symposia, which I think it's also very much important to activate, let's say, future generations, future engineers, because they are the ones that would bring, let's say, further advance in this world. And I think with FIB, it's really important is also traditional role, and that is really close link between science and practice. So, for example, with Ireland, it's less close to practice. So they are compatible actually. But I think this is really the strength of FIB. So that this is also something which is close to engineers and to engineering practice. And not to mention their role in regulations and in codes, so that I find amazing.
Well, okay, this has been really, really a pleasure. I mean, I'm so happy we did this. Thank you so much, for your time, for all the great messages, great insights that I hope a lot of our listeners or viewers will be able to hear and to take in, and hopefully, follow in your footsteps, and they can get in touch with us, with me, with you, I suppose, for anything that they need advice on or are interested in. Thank you so much, for being the guest of the FIB Young Members Group podcast. Thank you, Mladena.
No, thank you, Nikola, for inviting me. And I just hope that I managed to justify your trust. So I hope.
Absolutely. And this was never in question. So thank you so much, and well, thank you to everyone. Hope you enjoyed it, and stay with us for many more podcasts to come. So thank you all, and goodbye.